Alright, Monty and Miller here, Shadle Park, geometry, and we just got through Pi Day, right? Now, we got all these weird things, these circles, and then all these what are called special right triangles. Well, the first special right triangle is the 45, 45, 90. And you know a little bit about this because we saw doing this how to find the area of a triangle. Well, when we divide this in half, this hypotenuse has a relationship to the two legs, 45, 45, 90, special right triangle. Then, today we're going to look into this idea of an equilateral triangle divided in half. Okay? And we have the 30, 60, 90 triangle, and the hypotenuse has a relationship to the short leg and the long leg. So, special right triangles. That's where we are today. And Mr. Miller's handing out a sheet of paper, and we'll be getting started here momentarily. Okay. The mailer. On your mailer, on the back of the first page, are these identities. 30, 60, 90 has a relationship, and this 45, 45, 90 has a relationship, and we get all those from the Pythagorean Theorem. A squared plus b squared equals c squared. On Pi Day, we handed out what's called a unit circle, and we took some time to draw 30, 60, 90s, 45, 45, 90, 60, 30, 90. It's full of all these special right triangles. We need to spend some time to study and see what this is all about. Okay, so let's get started. On your paper, you ever notice how my head's always in the way? On your paper, you have a square box. Okay, so we have a square. And it's 1 unit by 1 unit by 1 unit by 1 unit. We want to calculate the measure of the diagonal. And we can do that using the Pythagorean Theorem. So, pause the video and do 1 squared plus 1 squared equals c squared. Okay? Go. Serious. 1 squared plus 1 squared equals c squared. Pause the video. Go. Okay, now the first thing I want to do is I want to draw this 45, 45, 90, okay? And this question mark here, this is actually called the hypotenuse. Okay, if you look on the back wall, Mr. Miller created a giant green special right triangle. Okay? We have a 90-degree angle, and across from the 90 is always the hypotenuse. Okay? All right. Now, for this discussion, we're going to call this leg 1 and this leg 2. Okay? Well, this is 1 unit, and this is 1 unit. And Pythagoras noticed that 1 squared plus 1 squared equals the hypotenuse squared. All right, what's 1 times 1? 1. What's 1 times 1? 1. And it's equal to this question mark squared. Well, we know what 1 plus 1 is. 1 plus 1 is 2, and it's equal to the hypotenuse squared. Now, we're all at different levels of our math career, but we have been discussing opposites. Okay? So, what's the opposite of plus? What's the opposite of multiply? All the buttons are located right either on top of each other or next to each other. Squared. What's the opposite of squared? What's the inverse of squared? How do we undo a squared? The square root. So now on your sheet of paper, if you haven't done this, we need to take the square root of both sides. Okay? The square root of something squared is itself. Huh? What? Let's just do that. 2 times 2, 4. 2 squared, 4. Undo a squared. The square root of 4 is 2. Okay, so when we take the square root of both sides, we get the square root of 2 is equal to the question mark, is equal to the hypotenuse. Okay? All right. Now you have that sheet of paper. Please, everyone, write that down. 1 squared plus 1 squared. Now, I want to put the square root of 2 right here. Okay? Now, let's do it again, but we're going to pick a number. Okay? So, everybody pick a number. Mr. Miller's going to call on somebody and we're going to put a number. It's a square. Okay? For this, the purpose of this video, let's just make it a 3. A 3. A 3 and a 3. Okay, and now this time we want to find the diagonal. Boom. Okay, and I always like to redraw the 45, 45, 90. Okay, all right, so we got a 45, we got a 45, and we got a 90. Okay, and it's 3 units by 3 units, and we want to calculate this measure. Now, we all know how to use Pythagoras. 3 squared plus 3 squared equals question mark squared equals the hypotenuse. It equals the hypotenuse squared. Okay? What's 3 times 3? 9. What's 3 times 3? 9. Now it's going to equal, and I'm just going to shorten it now to h squared. Well, 9 plus 9 is 18. And we got h squared. Well, we've been studying this concept of what's the opposite of squared? Square root. Okay. So now, put the radical sign over, put the radical sign over. Okay. Now, we all got an answer. Cool. The next week, we're going to spend some time on this. 18 is not a perfect square. Second square root 18 equals, 4.24. Now, it's true, h is equal to the square root of 18. The calculator says 4.24. Now watch. Now just watch. The factors of 18 are 2 times 9. The square root of 2 times the square root of 9. Does anybody know the perfect squares? Anybody? Anybody know what the square root of 9 is? Oop. Second square root 9. 3. 3 square root of 9 is 3. So we can say the square root of 18 is equal to 3 square roots of 2. Oh. Now, everybody, the hypotenuse is 3 square root 2. It's the square root of 18. It's 4 point something there. 4.24. Okay, now, the reason we spent some time is because we all like squares. We're good at squares, and we know that if one side is 3, they're all 3. I want everybody to make a big deal about this 3 radical 2. Then, I would like you to rewrite it. Just redraw it. 3, 3, 3 radical 2. Okay? Now, look at all that math on the board. Every time we have a right triangle, we've got to use the Pythagorean Theorem. No, 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 no. And we're going to use these special right triangles a lot. So we need a rule. We need a rule. We need a shortcut to calculating these lengths quickly. Okay? So now at the bottom of your paper, here's the rule. Here's the shortcut. Okay? Notice, now that we did this twice, 1, 1, 1 square root 2, 3, 3, 3 root 2, we take the leg, and the shortcut is multiply by radical 2 when you go toward the hypotenuse. Everybody write that down. We multiply when we go toward the hypotenuse. Now, pause the video, have a discussion. If we multiply going toward the hypotenuse, what do we do when we come back? Okay, and what I'm talking about is opposites. Plus, what's the opposite? Multiply, what's the opposite? Squared, what's the opposite? Okay, pause the video, have the discussion, and then we want to write what goes right here. Okay, Mr. Miller's got a giant board, and he's talking to you about what we do. Okay, when we go toward the hypotenuse, we multiply. And what's the opposite? All right, welcome back. So, if we multiply, first of all, it's a square. If it's a square, then this has to be a 7. And when we go toward the hypotenuse, we multiply and we have 7 radical 2. All right? All right. Now, we want to work on what's called an equilateral triangle. So on your paper, you have an equilateral triangle. The first thing we want to do is remind ourselves of what it means to be an equilateral triangle. So, take a moment and mark all the angles. 60 degree, 60 degree, 60 degree. What's that? All triangles have 180 degrees. 180 divided by 3 equals the 60 degrees. Okay? Now we're going to drop an altitude. An altitude is a line that comes straight down and creates a 90-degree angle. Okay, so everybody draw the 90 degree. You've already got the altitude. Now we created a 30, 60, 90 degree. Okay? Bisector rule. this bisected. Cut it in half because it was equal, 30 and 30. So now everybody on your paper, draw yourself a 30, 60, 90. Okay? 30 degree, 60 degree, 90 degree. Now we were given some lengths. What happened to my purple? That was 2. We don't know what this is. But when we drop this straight down, we cut it in half, and we cut it in half. What do you guys think is the measure of these two segments? Pause the video, have a discussion. Once we get the idea that a 30, 60, 90 is nothing more than an equilateral triangle cut in half, we have some magical things that happen. Alright, welcome back. There's a 1. Now, we want to use the Pythagorean Theorem to find the length of the long leg. So, everybody, let's write some vocabulary. Hypotenuse, this is called the short leg. This is called the long leg. Okay? Now Pythagoras taught us a squared plus b squared equals the hypotenuse squared. The hypotenuse is across from the 90. That's the angular one. Now, in this case, short leg is 1 squared. The long leg we don't know, but we do know the hypotenuse is 2 squared. Okay? Now, pause the video. Everybody, pause the video. And everybody calculate b. Calculate b. Okay, welcome back. 1 times 1 was 1. B times b is b squared. 2 times 2 is 4. Okay, balance the equation. What's the opposite of a plus? Minus 1, minus 1. We've got to keep it balanced over and over and over. We're happy. The 1's go away. We still have the b squared. We still have the equals. And we have a 3. Okay? Today's learning is reminding ourselves of Pythagoras, but understanding how to get rid of a squared. What's the opposite of squared? We're going to say it all day long. Everybody chant. What's the opposite of squared? Square root. Okay? So now, the little square root, the radical, and the radical. Now, square root of 3, just like the square root of 2, is not perfect. So we leave it that way. Okay, the square root of something squared is itself. Everybody write b equals square root 3. Then take a minute and go over and write square root 3. And go over and write square root 3. Pause the video. Everybody fill that out. Now, welcome back. Ready? All right. Let's try it again. Okay, in class, Mr. Miller is going to have you guys give some numbers. Okay, for the sake of this video, I'm going to use the number 5. Okay, 5 units, 5 units. Nope. I don't like 5s. Yeah, we can use 5s. That's fine. Now we want to create an altitude. Boom. An altitude bisects the angle and creates 90 degrees. In other words, we have created a 30, 60, 90. Everybody redraw it. And we know this is 5. Whenever we draw an altitude and it bisects the angles, it's going to bisect the other side. So this is going to be 2.5. This is going to be 2.5. Now I want the whole class to take a minute and try to calculate this. Okay? Yeah, I agree. Mr. Miller, Monty messed up, didn't he? This is going to be a lot easier if we do it in sixes, isn't it? Oh, I want to come back here. Let's make these round numbers. Oh, gosh, Monty. All right. 6, 6, 6, 3. All right. We'll make those 3's, okay? So the 3 is half, and the 3 is half. All right. And we got our 90, and we got our 30, and we got our 60. And our goal is to find the long leg, okay? So we have the short leg, we have the long leg, and we have the hypotenuse, okay? All right, let's use Pythagoras. Pythagoras said 3 squared plus the long leg squared is equal to the hypotenuse squared. 3 times 3 is 9. 6 times 6 is 36. Your algebra piece, the opposite of a plus is a minus. We're happy because the 9's go away. We're happy because we have the long leg squared. We still got an equals. 36 minus 9 is 27. The new learning today, let's draw a radical. The opposite of squared is the square root. The square root of anything squared is itself, and we get this 27. Okay? Now, watch. Rather than just type in second square root 27, rather than do that, I want to study the number 27. Square root of 27. Square root of 27. I'll bet you some of you can see that the 27 is nothing more than 3 times 9. And we're allowed in math, remember, A times B is the same as B times A, right? Square root of 3 times the square root of 9. Well, we know the square root of 9. We already did that once today, didn't we? Square root of 9 was 3. Boom. So in other words, this is nothing more than a 3. So square root of 27 is 3 radical 3. 3 square roots of 3. 3 times radical 3. Write it. 3 radical 3. 3 radical 3. Now, the reason we went through all that math, look at all that, is we don't want to have to do this every time. And in engineering, they try to reduce everything down to those 2 special triangles. There's got to be a faster way, and there is. Okay? Now that we did this twice, look at the poster. Can you see the rule? Okay? 1 became a 2. 1 became 1 radical 3. 3 became a 6. 3 became 3 radical 3. Here's the rule. Here's the shortcut. Okay? Now, in class, discuss. Multiply by radical 3. Double. Multiply by radical 3. Double. Okay, Now, if this is all we get done in class today, there's nothing wrong with that, because I need you all to understand that if we multiply going this way, then we have to divide when we go the other way. Okay? The opposite of multiply is divide. We've been chanting that all year. The opposite of multiply is to divide. So if we multiply this way, then we got to divide going this way. Multiply this way, divide going this way. All right? So this one turns out to be 2 times the square root of 3, and this is double 2 times 2, which is 4. Okay? And Mr. Miller's got those posters in the back of the room. He's got this little triangle that he's showing you. And you actually know this to be true because you did all this math. But from now on, we would like to not have to do all the math. All right? So, good luck. Enjoy this. We're going to spend like 2 weeks on these special right triangles. If you have time in class today, practice. Just in class. No homework. Everybody just kind of practice these. Here's a couple of 45, 45, 90s. Here's a couple of 30, 60, 90s. For those of you who got to come back, it's B cohort week. See you on Friday. For those of you that aren't coming back, have a great weekend.